Our next speakers are Maarten Schermer and Raoul
Goedenavond.
Schram, and their talk is entitled Integrating iRODS into Scientific Workflows.
Thank you. Hello, everyone. Good morning, good afternoon, wherever you are, whatever it is where you are. I'm Maarten Schermer from Utrecht University, and my colleague Raoul Schram and I will be talking about how we integrated iRODS into scientific workflows. First off, how did we get to work on this? Well, Raoul and me, and just as Christine, the previous presenter, are part of a team of research engineers at Utrecht University. And our goal as research engineers to help increase the impact of research through the use of all sorts of digital technologies. An important part of that is that we write software for researchers to help them in their work. And one of the things that these researchers have more and more of, obviously, is data. And as a result, effectively managing large amounts of data has now become an important part of their research. And to help researchers store, share, archive their research data, Utrecht University has developed the Yoda platform, which, of course, is based on iRODS. And I think our colleague Sirian will talk more about Yoda tomorrow. So please listen to that then. One of the ways researchers use their data is in so-called scientific workflow systems. And workflow systems are a class of software designed to compose and run workflows that consist of the required steps of computation and data manipulation that as a whole make up the research they want to do. And some of the advantages of organizing these steps into a standardized workflow are ease of use, reproducibility, transparency, and also being able to more easily share work and collaborate with other scientists. And there are many such systems in use in the scientific domain. Some of the most well-known are listed here: the Common Workflow Language, the Galaxy project, SnakeMake, and Nextflow are pretty big ones. And Galaxy and SnakeMake, for two of these, Galaxy and SnakeMake, we developed plugins to allow a better integration with iRODS. Last year, we got involved with a project from a group at the Expert Center for Genetics at the Faculty of Veterinary Medicine. And one of the things this group does is research into genetic variability in dogs. The data they use include, among other things, the DNA sequences for the entire canine genome. And currently, they have a data set that covers thousands of dogs. And on this data, they run various types of analysis. The size of this data, it ranges from 5 megabyte files up to files that are around 1 gigabyte per file. And this is expected to grow in the future to include even bigger files, even 2 or 3 gigabyte files per file. And at the time, they were using a variety of pre-processing and analysis tools, most of which were run through rather complicated shell scripts. And this way of working, they felt, had sort of reached the limits of the usability. So they asked us to integrate all these different tools into a workflow to make it all more usable. And for this, we selected Galaxy as workflow system because the Galaxy project was originally focused on computational biology. So it made a good match with the specific requirements for this project. And at this point, I should also mention that we did this with a third colleague, Matti from Met, who did much of the work on Fat Galaxy, but she can't be here today because she is enjoying her maternity leave. So Galaxy project. One of the benefits of the Galaxy project of the Galaxy software is that it is accessed through an interactive web-based GUI. And through drag and drop, users can select and configure the various steps they want to include in their analysis, so the various tools they want to put together into a pipeline and connect these steps by drawing lines between them, and in that way define their workflow in a form that is relatively easy to use and can easily be run and run again and shared with colleagues. And what you see here is a design layout of the Galaxy workflow. On the left, there's a list of available tools which can be drag and dropped and have their outputs hooked up to their inputs, much like you do in a flowchart. And I must apologize here for using a static image. I originally intended to give a live demo, but the Galaxy pipeline it can be quite slow to start. So in the interest of time, I decided to stick with some screenshots. But this is how a workflow is designed. And then when a user pretty much presses play, the pipeline starts running from left to right, passing through each step and passing the data from one step to the next. And I don't know if it's visible on the screen, but the modules at the beginning and the end of this particular workflow are labeled Yoda and upload to Yoda, I think. Because as part of FatGalaxy, we developed modules for downloading and uploading data from and to Yoda, our iRODS instance. Which doesn't mean that there wasn't already an iRODS component in Galaxy. There was already iRODS access possible before we started on this project. Galaxy has something called the object store, which can be configured to use, well, different data storage options, which includes iRODS. However, this is just part of Galaxy's general storage backend. So essentially all data of a running Galaxy project is written to the same storage using just a single set of credentials for the iRODS instance. However, the FatGalaxy project required a much more personalized use. Different users within the same running instance of FatGalaxy server should have access to their personal space within Yoda, and different researchers should be able to run the same workflow without risking or using or overwriting other researchers' data. And additionally, we also wanted to make our module to be more accessible to other Yoda or iRODS instances, just to make it more useful for future use cases. So what we did is develop an iRODS tool for Galaxy, or rather we developed 3 tools, one for downloading objects or complete collections, one for uploading them again, and a third one, an interactive one for browsing an iRODS instance from within a Galaxy project server. And tool development in Galaxy is relatively simple. Each tool is basically nothing more than an XML wrapper around the actual command to be run. And the wrapper also includes a definition of the input and the output hooks to be able to connect the module up to other parts of the workflow, as well as any relevant dependencies. At the same time, the Galaxy development documentation is quite sprawling, so to say, to actually get your tool to work and at times to be a bit of a challenge. So it took some efforts to actually be able to create these plugins. And as an additional to the tool development, we also had to alter the configuration of Galaxy itself to allow users to store their specific iRODS configuration that they wanted to use. So what the user has to do is essentially now copy the contents of the appropriate iRODS environment JSON file into his or her Galaxy settings and add their personal credentials, and they can use the plugin within their workflow. For the actual interaction with iRODS, we use iBridges, which you had heard everything about from our colleague Christine in the previous talk. And many of the advantages for users of iBridges are pretty much abstracted away in this Galaxy tool. But from a developer standpoint, it was an obvious choice, not in the least, I must admit, because I'm also a member of the team that develops iBridges. So it was a logical tool to use. Then there's Galaxy's preferred package manager, which is Conda. So we also published a Conda recipe in the bio-Conda channel as a proxy for the main iBridges package in PyPy. And furthermore, we published all the tools we made for FatGalaxy in what's called the Galaxy Toolshed, which is some sort of the app store of the Galaxy ecosystem, so they can be installed and used by everyone else who is also running Galaxy servers and using iRODS at the same time. So instead of an actual demonstration, I have a few more screenshots for you to see what that actually looks like. This is a close-up of a part of the configuration screen, Galaxy user's configuration screen. As you can see at the bottom here, the user entered the details of the specific iRODS server he wants to use by copying the contents of the environment file into this configuration field as username and data access password, and then have their personalized access from within a shared Galaxy server that they can use. And another overview here, this is what the browse tool that I mentioned looks like. As you can see, the browser is launched as a pop-up from within Galaxy. At the left, there is a running Galaxy instance. At the right, you see the browser window through which the user can browse to his or her specific iRODS instance, using the configuration and the credentials as seen in the previous screen. And it allows the user to explore the iRODS instance and also makes it easier to copy the sometimes elaborate paths to a specific object or collection on iRODS, which then functions as the input in the next Galaxy tool. So it takes away the frustration of having to find out exactly what the path is, which sometimes happens. Finally, some notes on the future work. Currently, the tool only uses iRODS just as a storage option, ignoring the possibilities of reading and writing, or reading and adding metadata, which Christine talked about in the previous talk. And we might look into adding that in the future if it is something that the researchers deem useful. Also, as iBridge is being actively developed, we also keep track of any new developments there that Galaxy users might benefit from and maybe introduce them also in the Galaxy tool. And lastly, we, to be honest, we just finished work on that Galaxy only very recently, so we're looking forward to the user feedback from actual use to see if there's anything that needs any further work. That's it from me, and then over to Raoul.
So yeah, I'm Raoul Schram, and I worked also on one of the workflow projects. Let me click. Okay. So one of the projects, so we did actually a call in 2023, and then we got one of the two projects is the Veterinary Galaxy project that you saw before, and then the other project is Mind the Gap, and that's a geoscience project with Emilia. I won't pronounce her name, because then I will probably butcher it. And she's really nice because she gives us chocolates, which makes our job even nicer than it already is. I did it together with also my colleague Christina, although she didn't work as much on the SnakeMake part of it, so that's why she's not actually part of this presentation. So it's about creating sediment curves. I don't know really that much about geoscience, so I just grabbed a screenshot from the GitHub page, and I mean, it looks very nice. So let's continue. So when they came actually in the first place to us, then they had a lot of questions about their workflow, because they were using many languages. So they at that moment they were using at least R and MATLAB. And now they're also using Julia, although they have like dropped MATLAB in the meantime. And then they have like a lot of different steps that go from like the R step, for example, creates like some outputs, and then the Julia step like continues on that output and then output something else. Then another R script will continue that. And so how do we manage all these different scripts together so that they keep working together? How do we store the data on our like local UU Yoda/iRODS system? How do we keep track of our data, because they're producing a lot of different runs with different parameters? So how can I ever find the data that with like a certain parameter? How do you deal with that metadata? Like how do I store it? Can we parallelize it, because it takes kind of a long time? And then all this together is kind of like going down like a stream, like a very wild water stream, like the picture on the right. And you just have to like avoid all the rocks, and so you get down safely. And maybe for someone who is like working on the project for a long time, you can like navigate all these difficulties. But if you have new people coming in and they have a lot of students that will have like a very tiny project inside the big project, for these new people, it's very difficult to navigate it. So first I will briefly explain what SnakeMake is. I mean, I see that I don't have so much time, so I'll go a little bit faster. So it's a command-based program, similar to Nextflow. It is used a lot. It has 14 citations a week, which I would be quite jealous of if that was necessary. But and then it is kind of similar to Make, but instead of a Make file, you have a Snake file where you have input, output, and then a command to create the output from the input. And one of the nice things about SnakeMake is that you have abstracted access to compute, so you can more automatically parallelize things to, for example, the Slurm cluster, and you have abstracted access to storage, which is of course why we're here. So I will just show you like very quickly. I will show you very quickly how a snake file looks like, so you have like at least a little bit of an idea. So on the left is the snake file. You can see like here, so the input is like a file. It has like metadata, and then the output is like a word count. So here I just like count like the number of words in the one, and then I put it in the output, and then count the input of the other one, and then put in the output. And first, to create this file and this metadata, it also needs to create those. those are done by this very simple Python script. So you can just see that it works, and then, oh, that is not the right one. And then you simply just have to run snakemake, and it will create, and you can see in the, so the one of the outputs is like the word count that you get like this file, and it will manage it on its own. So let me go back. So there is already an iRODS plugin based on the PRC, and you can install it already with pip install snakemake storage plugin iRODS. So why would we use iBridges? Well, of course, it's like same as Maarten said, we are like the iRODS developers, so that's nice for us. But it's also nice if you're already in the iBridges ecosystem, that if you know that it works, your plugin works with iBridges. If iBridges works for you, then you can just continue with. You know that the snakemake plugin also works, so there's like an integration, and then also the plugin itself is can be simplified when you use iBridges, because the commands are, the functionality is a little bit higher level. So one of the new features I added is to add wildcards. So then you can, I mean, those are of course a little bit snakemake specific, but you can like do something, for example, for all the samples in this case. And then you can also support for metadata, where you can store directly ingest the metadata from a local snakemake. This is actually the branch where I currently have it, and there is a proposal to merge it, but that will be definitely in the future. I will very quickly show how that actually looks like on the, so I also have another one where you can see the snake file. Here you can see that you can also have like input with the storage. So then here you can hear the data, snakemake knows that the data is here on storage, and it will automatically download and upload it. And then, I mean, you'll just have to trust me that this, so it will upload and download, and then everything is done. And then there's like metadata.json. So that is just very quickly, because I just don't have the time to actually explain it too much. And well, where is my, well, it doesn't want to. Well, I guess I'll just have to do it like this. If it doesn't want to full screen anymore, that is fine. So we, as a conclusion, we created two iBridges plugins, one for Galaxy, so for users that don't have any programming experience, and then for snakemake, for people who might have some programming experience but still want to improve the easiness of the workflow. So the few ways that they can make it easier is the reproducibility and the parallelization, and also how to like move data around so that you can easily store your data on Yoda, then read it, do your analysis, and then store the results back on Yoda. And one advantage of the snakemake plugin specifically, or like using these plugins, is that they don't need to understand the I commands or PRC, but they don't even have to understand iBridges, because everything is done in the background. And that is kind of what I wanted to say. So if anyone has any questions, then please ask them.
All right, thank you. Do we have any questions?
I see a question. Have you also used Nextflow for analysis? Shall I just answer the question now?
1 second.
Yeah,
Okay.
that was it.
Oh, he read the question? Yeah. Okay, yeah. Please go ahead.
So I have used, like we have for the veterinary Galaxy one, we have used Nextflow. But in that case, we didn't implement like we couldn't find a good way to like use like a plugin. So but we did use so we just manually with the command line interface uploaded with iBridges and downloaded with iBridges, which is also like a way you can do it, of course. So yes, we've used it, and I think for most researchers, snakemake will be a little bit easier to understand. Nextflow is just a little bit more complicated in like compared to snakemake. So that's why I think in general we would advise snakemake for most researchers.
I have one question. So you're building plugins for the iBridges application. In developing those plugins, is there anything that you feel would have that you feel the server should have provided that would ease that development process?
I guess I can first answer it from the SnakeMake side. I would say no. I mean, I think actually I would like SnakeMake to provide some interface for metadata, but that's, I mean, it's just not how it works. So I think it's more like the other way.
Yeah. All right. Are there any other questions? All right. Thank you.